So with end behavior, we need to talk about, we'll start with, I'll zoom in a little bit here. Basically, we're talking about as x goes two directions. X in a graph either goes to the left or to the right. So we're going to say as x approaches negative infinity, and the way we're going to write that is like this. X arrow and the negative infinity. And what that really means on a graph is as x goes left. I'm going to do that in a different color so we can see it. As x goes left. All right, so basically left side of the graph. That's what that means right there. As x approaches negative infinity or positive infinity, and that's going to look like x arrow positive infinity. I don't need to put a plus in front of it because it's positive. All right. The end behavior is what happens to the y values as we go to the left or right. The end behavior is determined by two things, though. Oops, I'm going to zoom out just a little bit. By two things. And we talked about those two things yesterday briefly in class. But today we're going to go a lot more in depth about it. We're talking about the degree of the polynomial, so we had to look at the exponents and figure out what the highest degree is. And then the other thing was the sign of the leading coefficient. Sign of the leading coefficient. All right, sorry, I moved out a little bit there. I'll zoom out a little bit. But the big things we want to focus on, the degree of the polynomial and the sign of the leading coefficient. Is it positive or is it negative? And like I said, yesterday we looked a little bit at degrees of polynomials at the very end of class, but we did not talk about the sign of the leading coefficient yet. Not really. Okay, so x approaches negative infinity. That means x is going to the left. The other thing that could happen, x approaches positive infinity. That means as x goes right. And in any graph, we're always going to have x going to the left, x values going to the right. And y values are either going to be going down or going up. That's true with any graph, any polynomial function here. So let's look at a few examples. Starting with problem 1, it says describe the end behavior of each graph. So what we're going to do first is we have to identify what's the coefficient or the degree of the polynomial. And there's nothing written, so it's technically a 1. And then the leading coefficient, that's the other part. So the degree of the polynomial, there's a 1, so it's an odd degree polynomial. And like I said, in this problem, it would just be a 1. The leading coefficient is going to be a positive number. So positive leading coefficient. Whenever there's not a number written there, you can just assume the number 1 is in front. All right, that's what a leading coefficient is. Okay. All right. So being able to identify the leading coefficient and the degree of the polynomial, very important. And that's going to ultimately let us determine what's going on with the end behavior. When we're writing end behavior statements, we're always going to write the exact same thing. As x approaches negative infinity, and we're also going to write down as x approaches positive infinity. And again, that means this first one, as x goes to the left. X goes to the left, what's happening? Is the y going up or is it going down? And to me, it looks like the y is going down. And we're going to use f of x because we're using notation, function notation right now. So I'll say f of x instead of y. F of x goes to negative infinity. It's going down. Part B, the second part, as x goes to the right, where's the function going? Is it going up or down? And it looks like this one, it's going up. So f of x goes to positive infinity. All right. And again, what it's really saying here is as x goes left, y goes down. That's what end behavior is telling us, just the direction that these functions are going. As x goes to the left, y goes down. As x goes to the right, y goes up. That's what we're trying to focus on today. We'll look at problem number 2. Problem 2 says x squared plus x plus 3. So that's written in standard form already for us. And it's x squared. Square 2 is an even number, so that's an even degree polynomial. Then leading coefficient, there's not a number written in front of the x, so we can assume it's a positive 1. Positive 1 is a positive number, so that's a positive leading coefficient. And I'm just going to say LC for short. Leading coefficient is the LC. And whenever we're doing end behavior, we're going to talk about the two directions that x goes. As x goes to the left, as x goes to the right. But we're using this negative infinity to describe going to the left because we're heading towards negative numbers on the x-axis. We're using positive infinity to describe going to the right because we're using positive numbers going towards the positive x-axis. Okay. Now this time, the first problem, as x goes to the left, it looks like y is going up. So this would be f of x goes to positive infinity. Second one, as x goes to the right, y is going up again. So this one would also be positive infinity. F of x goes to positive infinity. So positive infinity just tells us that the function is going up. That's what the y value is telling us right now. All right. Let's take a look at problem number 3 here. This time, degree of the polynomial, third degree. It's an odd degree polynomial. All right. Leading coefficient, that's also a 3, and 3 is a positive number in this case. So positive leading coefficient. And behavior, as x goes to the left and as x goes to the right. That's what we start with. What's y doing? So as x goes to the left, kind of heading down that way, it's going, y is definitely going down as x goes to the left. So y is going down to negative infinity. As x goes to the right, y is definitely going up. So it's going up to positive infinity. That's the idea with this one. As x goes left, y goes down. As x goes right, y goes up. Okay. Problem 4, the last example from right here, says x to the 4th, 3x cubed, x squared, x, and 3. So, whoops, the 4th, that's our highest degree, so it's an even degree polynomial. And leading coefficient on this one, there's not a number there, so we just assume it's 1. So that's a +1, positive leading coefficient. And then end behavior, as x goes to the left, as x goes to the right. That's what those two statements say right there. And as x goes to the left, negative infinity, we can see this function's going up, and it's kind of going up in both directions. It's going up there, and it's going up on the blue as well, on the right side. And so that means as x is going to negative infinity, f of x is going to positive infinity, because it's going up. As it's going to the right, this function's also going up, so it's going to positive infinity. That's what the end behavior means, all right? In a nutshell, that's what it's going to look like. Okay. Now, looking at the graphs, all right, what correlation exists between the degrees of the polynomial and its end behavior? So maybe we'll see between 1, 2, 3, and 4, we should hopefully recognize something with the end behavior based on those 4 problems. All right. And it has to do with whether it's an odd degree polynomial versus an even degree polynomial. So for example, odd degree polynomial, that was x to the 1st or x to the 3rd. It could be x to the 5th as well. It's affecting our end behavior a little differently than if it was an even degree polynomial. If it's an even degree polynomial, x squared or x to the 4th, we should see that both ends are going the same direction. And they were both going up. On the odd degree polynomial, we see that the ends are going in opposite direction. One of them was going down, one of them was going up. All right, one end going down, one end going up. That's what we should see on problems 1 and 3. Okay. Now, I've got 4 practice problems here. I want you guys to try these 4 problems out. All right, so take a minute, identify the degree of the polynomial, the sign of the leading coefficient is a positive or negative, and then describe the end behavior. So as x goes to the left, what's y doing? As x goes to the right, what's y doing? All right, so take a minute and work on those 4 problems now. I went ahead and started on these problems. So odd degree, even degree, odd degree, even degree, that's the 4. And then negative leading coefficient, it looks like all 4 of them are going to have a negative in front of them. One of them has a -3, but it's still a negative number, even though it's a 3. All right, doesn't matter too much. And then I wrote down as x approaches negative infinity and as x approaches infinity, because that's just as x is going to the left and as x is going to the right. Every polynomial function, doesn't matter which one, x is always going to the left and x is always going to the right. The y values are the ones that change. All right, those are the ones we need to determine. So for the first one, on the left side, it looks like it's going up towards positive infinity. So we'd say f of x goes to positive infinity. On the right side, going down towards negative infinity. Okay. Problem number 2, I think that's a little easier to tell because it's going down on the left side, down on the right side. So negative infinity, negative infinity. Problem number 3, up on the left side, down on the right side. Problem number 4, down and down. Oops. F of x approaches negative infinity, and f of x approaches negative infinity. And again, that's just as the graph's going to the left, this graph's going down, and also when the graph's going to the right, this graph is still going down. Okay, and it does some weird stuff in the middle, but right now we're only worried about the ends, what's happening on the 2 ends of it when it's leaving the graph, the view. Okay? Okay, now, big difference in the first 4 problems from the second set of 4 problems. And there was one big difference. What was the one thing that was different from the first 4 to the second set of 4?
Negative.
Yeah, there was a negative leading coefficient instead. You got it. So the first 4 had a positive leading coefficient, and the next 4 had a negative leading coefficient. And that negative leading coefficient changed the graphs quite a bit. So what can be said about how the sign of the leading coefficient of the polynomial impacts end behavior? It's actually something we would have talked about in AGS2 a lot, maybe in AGS1. It's a transformation. Whenever you put a negative in front of the leading coefficient, it flips the graph over. So the negative sign flipped the graph. That's what happened. Flipped the graph and the end behavior. Everything flips, and it's because of that negative sign. That's what's happening here. So that's the difference between the first 4 problems and the next 4. And those 8 problems are a very good template for you for general scenarios of what to do. We've got an odd first degree with a negative leading coefficient. We've got an even second degree with a negative leading coefficient. We've got an odd second degree or an odd first degree with a positive leading coefficient. So you can see the difference in the types of problems. There are 8 scenarios there. Each one with a positive leading coefficient, each one with a negative leading coefficient, and each one from degree 1 to 4. So hopefully we recognize that. Those are good to reference when we're doing the second part of what we're looking at today, which is graphing polynomial functions. Whenever we want to graph these things, we're going to do 3 steps. Step 1, we're going to determine the degree, the leading coefficient, and end behavior. Step 1 for graphing a polynomial function, we want to do that. Step 2, we're going to plot points to determine the general shape of the middle of the function. And again, it's just the middle. Step 3, we are going to sketch, and I'm going to underline the word sketch, the graph. And I'm underlining that word sketch because when we determine the end behavior, we know what's going to happen on the extreme ends of the graph. It's going to look maybe like a parabola, upside down parabola, something like that. All right. And then we're going to plot a few points in the middle just to give us an idea of what's happening in the middle of the graph. But we're really not going to do anything else yet. We're not going to get all the points plotted in the middle, just enough. And then that's why I say sketch a graph as the third step. So first thing first, problem number 1, I'm going to identify the degree. It's x to the 4th minus x to the 3rd minus 4x squared plus 4, making sure it's in standard form, and it is. So that's good. And it's a 4th degree polynomial, so it's even degree, and there's no number in front. So it's a even, and it's got a positive leading coefficient. Now, this is where I can use my information from up above. So I can do this without even sketching the graph. I can determine what my end behavior looks like. So I know as x goes to the left and as x goes to the right, I want to determine that end behavior. I can go back and say even degree polynomial with a positive leading coefficient. I'm going to go check my notes. Even degree with a positive leading coefficient, it went up and it went up. Even degree, positive leading coefficient, it went up and it went up. And that's a 4th degree too. Nothing else matters. None of the other numbers matter as long as we can identify those 2 features. Now I know what my end behavior is going to do. This is going up and it's going up on both the left and the right side. So I have no idea what my graph's going to look like yet, but I do know that it's going to do some weird stuff and it's going to go up on the left side, up on the right side. Something like that. We're going to figure out right now, part 2, kind of what's going on in the middle, a little general shape sense of what's happening in the middle. Okay, so that's what step 2 is going to be. We're going to now say, oops, this was step 1. Step 2, we'll create a little XY table. And we're going to plot a few points. Let's say, let's do -2, -1, 0, 1, and 2. And for step 2, we'll say, let's plot a point for y. I'm going to show you guys how to do this by hand, just in case. Odds are, though, you can probably do this on Desmos. But just so you can justify why your answer is coming out the way it is. We'll start with -2 to the 4th minus -2 to the 3rd minus 4 times -2 squared plus 4. That's what this would look like if I used the number -2 to plug in. -2 to the 4th is a positive 16. -2 to the 3rd is actually a -8, because it's a negative times a negative is a positive 4, times a negative makes it a -8. 4 times 2 is 8, and then I have plus 4. Actually, that was 2 squared, sorry. So that's going to be minus 4 times 4, and then plus 4. And now we'll go to the next step. That becomes 16 plus 8, and then minus 16 plus 4. So the 16s go away, and I've got 8 plus 4. I get 12. So f of -2 equals positive 12. That's just an example of how to do one of these. I always like doing 0. 0 is really easy because if I plug in 0, I'm going to get 0 minus 0 minus 0 plus 4. I like doing the number 1 because that's another one that's really easy. I plug in the number 1, I'm going to get 1 minus 1 is 0 minus 4 times 1 plus 4. All right, so I end up getting 0 for that one. All right, but if I plug in all my numbers, I use Desmos, whatever, to create a table for me. Those are going to be my 5 values for kind of the middle part of the function. Step 3, now I'm going to graph it. And I need to create a scale on my graph. So I'll count by ones on the x-axis. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the y-axis, because I have a 12 here, I'm going to count by 2. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, just so I can include that 12 on my graph. I'll go -10, -20. The last step, sketch a graph. I know what the end behavior is doing, so now I can go ahead and sketch the rest of my points. 2, 12, -2, 12, -1, 2, 0, 4, 1, 0, 2, -4. And I know end behavior says it's going to go up from the left side, and then when I go to the right side, it's also going to be going up. So if I didn't know what my end behavior was saying, it could be a little confusing at the end there, because I might think, oh, the graph's going to go down like this. But no, it's not going to go down like that, because on the right side, it's going up to positive infinity. So that's where determining the end behavior is very helpful. I don't need to get every single point that's going to fall on the graph to get my sketch going, but I need to have a couple points so I know what the middle is doing, and now I can see kind of what the middle is doing, and I already know what the end behavior is doing from part 1. That's what I'm doing for sketching a graph, okay? If you were to draw it on Desmos, you'd come up with something pretty quickly too. But being able to identify the end behavior, very important that we can do that. That's something on a standardized test you'll probably be asked to do. You might see this notation if you're a junior taking the ACT this year. You'll probably see this type of notation written down somewhere. So just make sure you're comfortable with it. All right, last example today says 4 minus x to the third. I noticed this one, wait a minute, it's not written in standard form, so I need to rewrite in standard form. Before I can do anything else. So I want to rewrite it as f of x equals negative x cubed plus 4. And now I can see, hey, there's a cubed, and it's a negative leading coefficient, which I might not have seen before if I didn't rewrite it in that order. So this is an odd degree polynomial with a negative leading coefficient. All right. Now I can determine the end behavior. Odd degree, so as x goes to the left, as x goes to the right, what's happening with an odd degree polynomial? What's happening to y? I'll go back up and look, odd negative. It looks like it was going from positive infinity on the left side to negative infinity on the right. So it was going from up to down. Okay, good to know. Going from up to down. And then it's going to do some weird stuff in the middle, but it's going to look something like this when it's all said and done. We just have to figure out what's going on in the middle now. All right, let's make a table, and we'll plug in some values, x and y. And I'm just going to do middle values again from -2 to +2. If I plug in 0, I'm just going to get a 4. That's nice and easy. If I plug in 1, I'm going to get 4 minus 1. That's a 3. If I plug in 2, I'm going to get 4 minus 8. That's -4. If I plug in -1, I'm going to get a 4 plus 1. That's 5. And if I plug in -2, I'm going to get a 12, because I'm going to get a -8 here, and then 4 plus 8 is 12. So because I have a 12, I'm probably going to count my y's by 2's again. And I'm going to count my x's by 1's. And what's going to happen now, I can go ahead and plot my points. I already know what the end behavior is going to look like. So I plot -2, 12, -1, 5, 2, 4, 5, halfway between there, 0 and 4, 1 and 3, 2, and negative 4. That gives me a pretty good sense of what this thing's going to look like. Now I can go ahead and sketch my graph. Might not have all the points, but I have enough to give me a decent sketch. Between the points and the end behavior, I have enough to know what my graph's going to look like.